All right, well, good morning, everybody. Happy Thursday. Somewhat colder than the last few mornings have been. If you've been outside, you noticed that. And if you weren't prepared, it was a bit of a shock. Nothing that clothing can't fix, so it's not a big deal. Let me cleanse some other of my workspace here. There we go. And chat window. And now the annoying thing doesn't want to be there. All right. I don't know how many people dropped the class. It's whatever the computer says it is. But getting 70 out of 90 participation, that's 70% attendance. That's actually not bad for something that's recorded that folks who are of the mindset think they can go watch the recording and figure stuff out. And in this topic that's probably reasonable, one could. But you'd have to watch the whole recording. Now, I checked the video statistics, and the most viewed video was the first one. That had almost 70 views. The next one since that have like 3 and 4. So nobody's watching the videos. It doesn't mean I'm going to stop making them. I'm just, don't say you watch the video 3 times, and if the video statistics say there was only 1 view, that's a hard case to make. You should need to save those kinds of statistics for presidential type behavior. They can get away with that. You can't. Okay, so yeah, there's my cheap political plug, which we're not supposed to do. Very good. Yeah. Okay. I'm sure everyone's watching sometimes. That wasn't my intent of the critique, but I was expecting numbers like up in the 40 views, and that would work 2 ways, because it would suggest that that particular topic didn't make a heck of a lot of sense when it was live. Okay, so plunging forward. Today's topic is... Oh, apparently there's a quiz that's hidden from you all. I'm not going to unhide it, because it probably means I haven't finished it yet. Today is lesson 6. And the title is Objects, Classes, and File Manipulation. Now, of those 3 keywords, by far the most important one that we need to get our minds wrapped around is file manipulation. The other 2 are fundamentally important for the whole programming experience, but you literally can be an accomplished Python script author and get Python packages to work and have no flippant idea of what an object or a class is. For example, I'm living proof of that assertion. I only vaguely know what objects and classes are. I've never been able to wrap my head around the computer science meaning of them, so I just have to accept them as they're just sort of some kind of special kind of data structure and proceed forward. If that works for you, I mean, that's fine. If you actually get your head wrapped deep into these, you probably should be teaching this course. So let's begin with the lesson. So class, objects, and file handling. And our outline for today is classes and objects and files. Files we know a lot about, me and your teaching assistant. We'll be able to make meaningful progress there, but we're going to go through classes and objects quickly. And the objectives are to understand the use of classes and objects and do effective coding in Python, which is always our overall objective until we get to the data science part of the class, in which case we're doing data science. And to understand the basic idea of how to manipulate data in a file using file handling options in Python. This is today's objective. The other one is just kind of nice. It's like the frosting on a cupcake. I'm saying that because for breakfast I have my muffins that I made. These are made with sour milk. Perhaps you all have had milk in the refrigerator turn into a biology experiment and it gets chunky. Most people throw away chunky milk, but you can bake with it. You make really good biscuits. Really dry biscuit. Classes and objects fall into the decomposition and abstraction subsets of computational thinking concepts. Ew! Chunky milk, once you bake it, is yumster. Oh, show me the recipe. It's right there. You put all the parts together and you bake it for 12 minutes and it's done. They're actually much better fresh out of the oven than a day later, but it was all I could grab in a hurry. They're part of the decomposition and abstraction component of computational thinking. The benefit of both, a class and an object, is we can decompose a problem, and maybe a problem has features that can be defined as a class. Now I'll use a classical, pun intended, example. People that study animals, one class of animal is a cat. Okay, so that's a class. Within the class of cat, there's different attributes. Cat weighs over 300 kilograms. That actually makes it a lion. Cat's red, green, blue, purple. They have an attribute of color. They have an attribute of mass. If our cats are anime cats, they can talk, so they would have a name, and so on. So the class would be cats, and the different unique features of an individual cat would be a set of attributes associated with that cat. And a class in Python allows us to construct that in advance, so we can create the cat class as a object. Think of it as a data structure that has all the spaces in it for whenever we need to create a cat in our program. And including the attributes, we also can include methods. Cats have methods. They can meow, so they can be the meow method. They can jump. There's the jump method. They can chase birds. It'd be the chase bird method, and so on. File handling is it focuses the decomposition component of computational thinking. File handling is far more important than just file handling is decomposition. It is the primary way, historically and presently, that data are provided to a program for the program to operate on that data and for the program to produce output. It's all managed between file reads and file outputs. Even image files are just files. So when you take a picture on your phone, you save it in the raw format. That's a file, and it has nothing but zeros and ones in it. Usually in hexadecimal, so it has funny-looking characters in it if you look at it in a text viewer. And then put into a graphics program, that program knows how to interpret those characters to replicate the picture. So file handling is really important. But first, classes and objects. So what is object-oriented programming? And the acronym is OOP. And then if you have plural of object-oriented programming, you get OOPs, which happens a lot. It's a useful paradigm, which is a fancy word for model. So if you're around uppity people and the word model isn't cool enough, use paradigm. They'll either think that you're talking about 20 cents or that you're using the fancy word for model. It's a useful model where classes define concepts, relationships, and objects are instances of those classes. And it's a way of thinking and creating code. So we'll go through some simple pedagogical examples. So let's suppose you were tasked with how to describe an apple to a person. You have a couple choices. You could start with telling them it's a fruit or a major hardware company, but that's a different apple. It has color and flavor, and you could add more attributes to it. But it's a fruit, so fruit would be the class. Color and flavor are attributes. Now, how would you describe an apple to a computer? That's where we have this object-oriented programming concept, because we have to tell the computer not only it's a fruit and it has color and flavor, but that those are attributes and classes respectively. So to talk to a computer, we would create a class called the Apple class, and in that class it contains characteristics of an apple such as color, flavor, weight, percent ripeness, and so on. Things that we perceive as ordinary descriptive variables. And then anytime we want to use a particular apple, we would define an instance of that class, and that instance, once it exists, is called an object. We can create many, many instances and hence many objects from the apple class. And another way to perceive that is a class is a set of instructions to build something. So if it's a house, you can think of class as a blueprint to build a house. You can build many houses using a single blueprint. In fact, that's the basis of the modern subdivision. So you civil engineering students in this class, that's a funny pun right there. This will be a big part of your future, is how to take a blueprint and take a few hundred acres of ranch land and turn it into running rat acres, a gated community for people. The overall process is called object-oriented programming. And the core concept is attributes and methods. So those descriptive things such as color, weight, flavor, percent ripeness are attributes. But what we do to apples are methods. So methods can be equated to functions that are associated with a particular class. And attributes, think of those as variables. So actually we've been using object-oriented the whole time for this course without even thinking about it, because our main programs, if you will, have attributes and variables and have methods that are functions. Braden, methods does not equal functions. They are related. So these are analogs. A more relevant example might be accessing a file that contains data. So the attributes of that file would be its file name, its overall size, its creation date, And furthermore, the attributes would be the individual records. There would be the end of file marker, an invisible marker, and there'd be a type on whether the file is binary or text. Methods would be functions associated to a type. So we could actually have a method that describes how to read that particular file and how to modify data in a particular file. And the built-in methods for those things are read and append. And there's write, and there's a few other methods that are associated with the class file. And file happens to be one of the built-in classes. So numbers, strings, lists, dictionaries, when we create them, once they're created, they become objects. But when we did the creation, we actually were using a class constructor model, and so each of them became an instance of a class. So for example, print type integer 0. The output we see is that the 0, the literal 0, is a object of class integer. We do the same thing for print type string, an empty string, and it returns that it's the class type of string. And then last one, same for a list. So this list down here, 1, 2, 3, 4, that's a list object. That is a particular list object. It exists at the moment it's created, and in our way we've been creating it, it would usually be associated with some name. In this particular representation on the screen here, it has some internal assigned name. So, and the name is funny looking. It'd be like 006XE and a whole bunch more letters. It actually has its address space in the computer until we give it a human readable name. So that object exists, and then the type function is applied to it, tells us it's a list. The print function is applied to that, and it prints out the statement class list. And as we continue, if we don't do anything else with that object, it's kept around until such a time that it just gets destroyed automatically. So I don't think I'm going to do the demonstration, go to CoCalc on this. I perceive that most of you all have made it clear to Farang and I that you can look at this stuff and understand what's expected. Oh, I will actually take that back in a second. I am going to need CoCalc. And see if it's got good. I don't have to log in because it sets a nice permanent cookie. The usual request for money. All right. Let's see if that can be cut. No, I have to do let's create a variable. And I'm going to make a string. It's my party. There, it's my party and I'll cry if I wanna. Alright, so there's my variable, and I will print the type of my variable. So we already know my variable is a string class, and we'll use two methods on it. The type method, which determines what class my variable is, and then we'll print the output of the type method. We do that and it says class string. So that's basically this page. Now if we want to display all the methods associated with a string class, we use the keyword dir. So the example says do dir of a blank string. I'll try that and see what happens. And these are everything we can do to a string. Notice this funny syntax right here with the double underscore, some sort of characters, and a double underscore. These are class constructors, which are different from methods such as capitalize, case fold, is ASCII, and so on. Split, someone asked the other day if you could enter two things on one line, and you use the string split method a lot. And I think upper should be in here. There's the lowercase method and the uppercase method. So let's apply the uppercase method to my variable. And it's a method, so you would do a my So we're saying my variable upper, we want to operate that method on my variable, which you already know is a string. And there we go. Let's look at another one of these while we have it here. Let's try capitalize. What I think that will do is capitalize the first letter. Or won't work at all. Maybe because I can't spell. C-A-P-I-T-A-L. C-A-P. Stupid spell check. There we go. It capitalizes the first character. And now as an experiment, let's see what happens if we do a directory on my variable, which is an instance of a string. Oh, I'm surprised it did that. That's kind of cool. So if you forget all these different little things it can do, during programming, while you're trying to build your fancy program and you need to do something, you can always use this dir function to find out the various methods that are available to you and the various class constructor methods that are available to you. And we can try help. Let's look at the help function. And this says there's no documentation found. Let's just try help on a string. That sounds like another bad movie. Snakes on a plane, help on a string. So if you just enter the string class, it describes what each of these methods are and what each of these constructor methods are. So the constructor ones can be used on objects that don't exist yet, and they're created when you create the object. And these other methods are applied to objects that already exist, and that's part of the different syntax. So we've been using built-in classes and objects for quite a bit. And just so you know, get an experience, we'll define some of our own classes just to see how. So we're going to create a class called Apple, and it's going to have two whole attributes, a color and a flavor. And then later on we'll create an object. And make sure I'm doing this right. Yeah. Okay, so the keyword. So I'm only like a couple seconds ahead of you guys. I need you to go away. Good. So the keyword for defining a class is class. And we're going to name our class Apple, and by convention, classes usually have a capital letter for their first letter. So here we are. And then our next step is to be we want to document our class, and I'm actually going to have to read forward on what the syntax for documentation is. He has no examples. There we go. Triple quote. Okay. Get back to my Apple class. This is so that's called a documentation. It's different than these kinds of symbols, comment lines. It specifically has this triple quote structure. So we've now defined the class, and usually your message there is something a little bit more meaningful than that. I'm just being a smart aleck for example purposes. And then we create the attributes. Those should be indented, yeah. Tab. Flavor. And there is our Apple class defined. And now we're going to go ahead and use it. Let's first run it and get any errors. Okay, can't be there. I bet I forgot a colon. No, I forgot to. There we go.
Dr. Cleveland, can you please make your screen in full screen mode? Thank you.
Of course, now I can't refer back and forth, but okay. And the colon sign. I knew I needed a colon. If you do colonoscopies in Python, it just doesn't work. That, I think, needs to be indented. Yay! Okay, so there's our Apple class. And now to use the Apple class, we will create an object named Gala, which will be a type of apple, and an object named Crips, which will be a different type of apple. So Gala is an apple. Grips, yeah, we'll have a Grips apple, is an apple. So we've now created them. If we do type Gala, it tells us that it is a object of the class apple. If we do type Grips, we get the same output. Object of type apple. Gala color equals an orange, so we can have apples that are oranges. Except I better turn that into a script. I mean a string. And nobody likes Grips apples. They're yeah, I don't need the. I'm checking the syntax when I go back because this is uncommon for me. Okay, so we hit enter. And now we've assigned its color, and we can also assign Gala flavor. Gala is, of course, yummy, an important flavor. Grips flavor is yucky. Okay, so now we have two objects, Gala and Grips, both of class apple, and we've defined their color and their flavor. And then at that point we could find we could query what those are. I think if we just do this, we ask it for the flavor method, it didn't work, so I don't have it done right. So don't do that. Erase that from your mind. So methods are functions that operate on attributes of a specific instance of a class. And so in this example, we have the class name dog, and we're going to find a function called sound. It operates on self, so it operates on its own class. And when we invoke the sound function, it will print woof woof. And so earlier they've defined a dog with name, fudge, and maple. Let's go ahead and create our own version of sound function with our apples, so we don't have to recode stuff. So we could go up here and define am I yummy? So now we want to print no, I'm doing that wrong. Never mind. Go away. We'll just follow the dog and sound instances. In fact, let me take advantage of something I just realized. Give me a new window. Cool. I think I have all those examples already built. Oh, except the computer's not going to run right now because it's live. There we go. I think a lot of these already built. Namely, I'm looking for the dog example. So here we define the Apple class. And this is very interesting right there. The author defined a null class and then went ahead and added attributes to it in a later definition. That's actually fairly cool programming method. I never would have thought of that myself. And then created the two apples from the class. But let's do dog here, where we have dog, and in the dog class we can define sound, and then we will create two dogs, Fudge and Maple. So I'll go to CoCalc. I'll do my dog definition. So let's look at this before I run it. So we have a class called dog, and in that class there's a single method called the sound method. And the sound method creates the sound for self. So if anything that's a member of the class, it gives its own sound. And then here we create a dog named Fudge and another dog named Maple. I've intentionally turned those off so that we can learn about so if we ask what type Fudge is, it's a class of type dog. Now if we take Fudge, which is a dog class, and ask it to generate a sound, it barks, woof woof. We can do the same for Maple. Woof woof. So Maple is the name of the object. Maple is of class dog. Sound is the method that a dog object can make. Sound operates on self, so it doesn't need any further external input. And when Maple, a dog object, calls the sound method, Maple prints the string woof woof. And from there we can build very complicated, almost unmaintainable programs. Get out of the way! Methods can also be used to do mathematical operations. So here's another example. So in the dog class, we'll instantiate every dog with an age of 0 years, and then we will have the dog years method, which when you set the dog class years variable to any number and then print the dog years, it gives us how old the dog is. And we'll just go back and look at the example as soon as this thing will get the F out of the way. Oh, if it stays down there, that would be seriously wonderful. Because I'll go back to full screen. Oh, that's why that only took 2 weeks to figure that out. So there's dog class, and my little fancy server has to be restarted every 15 minutes. Find the right one. There we go. We will add that to our dog class. So here's our new class, dog. This statement here instantiates, so every dog starts out with an age of 0. And then later on we can change that age. We have a method called the dog years method and a method called the sound method. We can return to our 2 dogs, Fudge and Maple. Let's we'll make Fudge 3 years old, young pup, and we'll make Maple 14 years old, kind of an end-of-life pup there, or getting near the end of life. And we will have it report their Fudge's age in dog years. And Maple's age in dog years. So we're taking our dog class and adding a little bit of functionality to it, unless I broke it. Oh, I didn't really do much with that. I need to print the dog years. So Maple's an old dog if you assume that they have 1/9 the lifespan of a human. And Fudge is just a young adult dog. Then a constructor is a way of, when we did dog years, we just explicitly assigned it at instantiation. That's when we create the object. Another tool is to use a Constructor Syntax to instantiate several different variables or attributes at once. And in this case, here we have the dog class, and then when it's initiated, the class itself, dog, or whatever the object is, has an object called name and years, and those are initialized in the constructor. And we can go take a look at that. Right here, and if we look at the syntax, when we initiate fudge as a dog, we can give it its name and its age upon instantiation, rather than do like we did here and then subsequently assign that. So let's go ahead and keep these functions. You know it was so hard to make a dog, huh? So now we have the ability to instantiate it. Let's go ahead and run it. Hopefully I didn't introduce a new error. I did not. Now if we do fudge sound barks, we do fudge we'll print his dog-earness. And so the initiator or the constructor gives us the ability to automatically pre-assign attribute variables for any object that's a member of a class. And so as you can see here, it makes the object easier to define rather than having to do the explicit assignments here. Because you can visualize it in a more complicated case than this, dealing with engineering stuff instead of dogs. Explicit assignment for each initiated class variable would get to be a nuisance quite quickly. So now we ask the question, can we write a class so that the dog can say its name and age? And here's an example of how to do that. We would just take the class and we would modify the sound class and have it state what its name is. And this syntax here, wolf I am, and then the curly bracket takes the dot format self name and inserts it in that location, and then continues on with the string. Now let me check what the time is. Oh good, we're good on time. We'll try this one. I'll just copy this from the example, because actually I'll just run it right here. Let me clear it. Okay, so here we have the class dog. The initiator sets a name and years as variables, and then we have the dog years method, and we have the sound method. But the sound method's a little different because now it's going to put self name into this location and dog age into this location when we run it. So let's go ahead and run that. and nothing happens because there's no kernel. There we go. I am Fudge, I'm 18. I am Maple, I'm 13.5. So that's pretty cool. And it's not too hard to imagine that you could create some very complicated classes with this. So we just did this demonstration. Now, document strings are a method of explaining the purpose of the class, and as we saw earlier, they're typed between triple quotes. They work quite similar to a comment symbol in an ordinary Python script that you've studied already, but they are specific to class definitions. And we'll actually pull this example again from here. So here's one that shows document strings. So when I run this script, nothing happens because it refused input. There we go. So it wasn't very interesting. Let's run it again. Same output. But let's say we forget about the document string and use an ordinary hash in the definition. This may or may not fail. In this case, it didn't fail. But the document string is accessible from outside the class. So this is a commenting method. I was curious about something. So my kernel on my home machine works completely different. Let's see what happens if we do it here. Oh, I guess works. Okay, so I take that back. This is just a convention for documenting content in a class. Their purpose is to make it easy for other people to understand our code. And here's why they exist. If we use the help class name, it will return the document strings that explain the classes and methods. So let's go ahead and test that conjecture. Let's go for help dog, run it, and it says help on dog in module main. The class is dog, the built-ins are dog name and years, methods are initiation, the sound method, data descriptions are shown here, and all that is a function associated with document strings. So that's where they're useful because they can be parsed by this help function. Okay, that I must admit is really cool. Now let's get to file handling. Let's see how much time we have on that. Oh, we got 30 minutes, so let's begin. Let's actually go take a look at, well, let me read this slide to you, and then I'm going to go take a look at my Jupyter Lab layout here and point some things out. So Python has a built-in function called open. And the open function operates on file objects. And if it's a file object, when you invoke open, you can give it four modes. There's actually more than four, but these are the most used. There's the R mode, which opens a file for reading and positions. You can think of it as it positions the pointer to the top of the file. There's W, which opens a file for writing, which also positions the pointer to the top of the file. There's A, which opens a file for appending, and that positions the pointer to the end of the file. And then there's X, which is used to create a file. W, A, and X can work on files that don't exist yet. R assumes the file exists, and if it does not, it will return an exception, and we would be best to use a try except to catch that, or just let the operating system catch that and shut everything down. So now let's look at this actually is good enough. Let me see if it has file handling. Okay, so here's an example of, we're going to open a file named sample.txt for reading, and we're going to assign that to the object called sample file. And this is a pretty common syntax. This is going to be used to read what's in sample text, and we will think of it as associating a connection. The object sample file and the file sample text become the same thing, and then we can do other operations on it. Now I want to look at my file system here. And in this file system, we see a directory called lab6, one called original PowerPoint, pseudo lesson, class objects, blah, 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 PowerPoint, a couple of Python notebooks, an HTML file, which is actually the web page, because we're actually on the web server, a file called capital R reading file.txt, and a file called capital sample.txt. Notice the capital S. So here when we try to open sample.txt, we get this error, it can't find it. What's going on? Well, we will change this to a lowercase. Now the file exists, and when I rerun that, we were able to open it. And now we can read, use the read method on sample file, and we will print the read. So before I run that, let's go see what's in sample file.txt. So it's got five lines. Hello, my name is Bob. I live in California. I'm 21 years old. My major is sinful engineering. I have 2 pet dogs. Good luck, Bob. So now we'll go ahead and read that file in our Python script and then render it back to the console. And it does as expected. If we want to add a new line to the end of the file, so bear in mind, there's one thing. Okay, so we've done that. Let me add hopefully I remember the syntax. When you're done with a file, you should close it. And it's super good habit to do it. Let me be sure that actually is going to work. Good. So we've closed the file, and let me split the. Want to do that as a separate operation so we can still read the file. All right, we're going to read the file, open the file, read the file, close the file. So if we were to try to read the file again without opening it, there's no connection, and it just sits there idle, or it gives us an error message. So now we're going to open the file again right here. So sample file is now open, and we've opened it in the append mode. So what the append mode means is that the internal pointer is right here. And so if we try to write something to it, it's going to write to that next line, that line 6. If we open it in write mode, the internal pointer is going to be up here. And when we try to write to it, it's going to start writing up there. We'll do an example shortly. We'll actually build on this example to do that. So let's go ahead and open the file for appending. We've done that. Bob likes dancing and playing tennis. I guess living in California, that's a good thing to like. So the write is complete, and then the 42 has no significance. I think that's just the return code from the write object telling us how many things it wrote. Let's go take a look at sample file right now. We need to close it. Save changes. I'll rerun it because there we go. And it has failed. That's weird. Let me close it again. Open it. And it picked up all those writes. So what you saw me doing was I was switching between the operating system and the script, and there's a bit of a causality lag there, so it didn't pick up the reads. Let's return the sample file to its original state. There we go. And if we run that, it's back in its original state. Now we will open it. I want to modify this for a W. We're going to write to the file, and it's going to notice what happened. When we open it up in write mode, we completely clobbered the existing materials that were there. So be very careful in writing that you mean to write or you mean to append. Let's take advantage of our little cool tool here, and we will restore the file back to its original status. Paste. Save. Let me duplicate it. There. So now, open it for reading, close it, open it, write to it, open it, ta-da, and there's our file handling examples. This is a really simple example, and this activity is vital, and that's why I recommend that you always explicitly close a file when you're done with it for whatever you're doing. If you leave it dangling open, you can accidentally write things to it you don't intend to. Sometimes if the program fails midstream and you have the open files, everything gets all garbaged up. You should always close a file. So here we have reading a file named sample text. We've just done these particular exercises. And here's how to print the entire contents of the file. We can append things to the file, and we can write text to it. Let's take the few more minutes we have before lab, and let's look at some other cool tricks. Another way to look at a file is to look at it in the operating system. And this is import sys. I have to go quickly look at import sys. Okay. You'll be doing this shortly. So what this command does is this imports a package in Python that allows it to interact directly with the operating system on this particular server. So now if we want to look at the contents of this directory, bring your eyes over here to the left side. So we have Lab 6, original PowerPoint, some other stuff there. We put the bang symbol there and type ls-l. That's a bash command that the operating system understands. It says list the contents of the current directory. And I hope I'm in the current directory. And there it's giving me the entire contents of that directory. Even shows me these other two directories which had the D in front of them. And if I want to look at the contents of the file at the system level, type the cat command, just like the cat that jumps on the table all the time, and it tells us what's in the sample text. And let's look at sample copy.1. Okay, I introduced that. Your next lab, we have you do this a few times, and mostly so that you can associate that the files are living in the computer's file system, and you've only accessed and written and stuff to them through the Python script. It's an important concept. It doesn't have to make entire sense today, but over time it should. And we can look at other things if we wanted to. Of course, you got to type the whole command. If I run that, it's going to show me the contents of this styles.css file, and that's everything that's used to make the web page look all cool and pretty. So most of what we do is all ultimately comes down to various files that are being read and operated on. Okay, so that brings us to the end of the lesson. So to summarize, we discussed briefly concepts of class and objects in Python, and we built the dog class. We looked at constructors, and we looked at a couple of methods, really simple, just to get introduced, and then a very brief introduction to file handling modes in Python. You're going to get a lot more of that in the lab that's coming up shortly. So let me modify the sizing here so I can see what's going on. And okay, looks like someone else has been handling the chat room. Very good. Let me set up the lab. I will close that down, that down, that down. That's our class, lesson 6. And I'll get my copies. Go to lab. And this lab has two parts. It has a part on classes and a part on files. Both parts are due. You have to do both parts. Hopefully I'll set that thing up to have multiple sheets, or otherwise I'll have a lab 6 part 1 part 2 on the Blackboard. I forgot about that because Blackboard is really good at denying things. So we separated the two parts literally because they were written at different times in real world. And so you can either we're going to go through the full narrative today, but for the turn-in part, you can choose to do your work in the worksheet only, render that, and submit that to Blackboard. I need to get my copy. Full narrative and files full narrative. So I've got them downloaded, and now I will insert them into my CoCalc. I'll briefly go over them for about a few minutes, and then I will hand the heavy lifting off to Farhang. So here's the Lab 6 full narrative. This preamble is optional, but I think you need to keep this block at the top of your notebook. If you don't, these tables don't line up on the left; they line up out here in the middle, and it's a real nuisance. So this is just a script block that that left aligns markdown tables. This one's optional. I would just leave it because I'm lazy. And if you're to run it on your CoCalc, you get output that looks like this. It tells you that we're in Python 3 and username is user and the host name is this long string here. And it's running Python 3.8.2. There's an introduction to classes, some narrative regarding classes, and then if you want to learn more, there's a good tutorial here at python.org, and you can look up what a class is on a Wikipedia, and it's probably in your best interest to take the time to read those, not right now, but at some point in the near future. And then there's an example where you will create a class called personnel, and you'll have attributes of personnel such as employees with first names, last names, and age. Not much different than cats and so forth. And then looks like, oh, that's the office. I know those people. And then, given that we're living in the creepster year of 2020, we want to use the script and modify personnel class to determine the year each employee was born. So you would take 2020 and subtract off the age, handle the necessary 1990 flip, and so forth. Then your second exercise is going to be a car speed class where you'll have different brands of cars. They have different distance. They've traveled different distances over different times, and you want to determine the speed. And then you want to produce output where you get the speed of the different cars and you determine which one has the highest speed. Third exercise is a tax class, and you can have the employee, their annual salary. This, I think, is a typographic error. Unless you intended to make 1.5 million, you're missing a zero. But I think it's 150,000, 175,000. And then getting the notes. In this case, you want.
That was my bad.
Did you mean the 1.75 million or?
No, just 150,000.
I'll let you walk them through how to fix the markdown. It's
yeah, sure.
It's easy enough. You just do that. But that's only fixed in my copy. That'd be good training anyway. So that's part of the lab. We did that on purpose. We just made it look like an accident. And then go through the tax exercise. This unintentionally has code in it. Okay, and so that's classes. Let me go to the other one, which is files. So files, I don't, same statement here. This is useful for making the notebook look good. This you may choose to keep or delete. It won't affect its functionality. I'd suggest just leave it there. If we run it, again, it tells us that it ran on CoCalc. And then quite a bit of narrative on files. This should be read because the file manipulation is an important part of any kind of data science. And there's a few extra things. I discussed this in the lesson. So this you won't normally do, but this is a way to find a file. In this case, this deletes a file. If the file doesn't exist, actually I don't know what it does if it doesn't exist. It's fine. It's fault tolerant. And we're in directory home user. List the contents. So there's not that many. And then it goes through creating a file example, listing the contents of the working directory, showing what's in the first file. And then the next example is reading from a file, so you read from that file. The next example is update the file. And this has a rather unusual structure right in here, and there's narrative explanation here what it's for. So as you run it, you look at the output, you can see what we're doing. If you want to experiment, you can see what happens instead of using this join method for lists and strings. You could see what happens if you just assign my list to what to add and write that. You get an interesting result. It won't break anything, it's just different. And then the last one is how to delete a file, and just how you would do it from your notebook script. I wish I could say don't do this, but there might be needs to. Be aware that in the deletion game, it's lost forever. So you can either delete using this command and importing the system package, or you can import the operating system and use the remove command. The second one is probably the better way because it's not fault tolerant. If the file's not there, it throws an exception. And so here's some script to handle that. And when we run it, it either deletes the file or tells us it's missing. Then we have some more example, and then your exercise. Exercise 3 is to print the contents of the file name reading.txt. I guess I should be sure it's there. Oh, that's going to be a bit of a problem. While Farang is setting up the lab and talking you through it, I will get those files moved there. Actually, I can't do it. I'll do that. So it's a good thing we did this. And you have some exercises to do there, and then appending text, and then that is your exercise, your laboratory. So let me hand off control of the machine to Farang. If I can find you. There you are.
Thank you.
And while you're doing that, I'll move those necessary files into the space. That was a screw up on my part. Again,
Are we going to do a break or not today?
Well, I'm just going to move files around, so if you want to break for 5 minutes and come back at 9:30, that's fine.
Yeah, I'm going to be here if you have any questions, but we are going to start the lab at 9:30. So.
All right, Frank. So my question about lab 4, exercise 5. Okay. So I decided.
Can you wait one moment because Dr. Cleveland, can you please stop sharing your screen?
Oh.
Thank you very much. Sorry.
Okay, so in lab 4, exercise 5, I couldn't figure out how to properly make it to where my accept statement, my try accept statement, works with a a float. So I can make it to where the except statement would work with the integer, but it wouldn't work with a float. Anytime I used it with the float command, it would just crash my code and it wouldn't keep working.
So let me see lab 4 exercise 5. So here is actually a code from one of the students that we were working on in my yesterday's office hour. One moment. So basically what you can see here is that you have